And I think we have the same alumni. You are both Amazonians. You also global financial systems around Europe, I think. Right?
Yeah, England and that's
Yeah. So very interesting. Doctorate from Hebrew University in Jerusalem. It's another great school, well known. So with that, I will turn you over to Dr. Talby.
Thank you very much. Hello, everyone. It's a pleasure to be here. I'd like to talk to you today about translating specifically medical expert knowledge, but it applies more general to turning
let me go to the other one first.
Expert knowledge into responsible language models. So first, I want to talk a bit about the process that we often see in healthcare settings. Okay, and here's the usual problem. You have clinical documents, and there are lots of modalities in healthcare that are not structured data or not sensors, right? That are text-based or imaging-based. Pathology reports, radiology reports, lab reports, vitals, next-generation sequencing reports, MRI, imaging, X-ray, CT, and so forth. And what you want to be able to do at the end, whether you're doing just dashboards analytics or whether you're doing patient risk prediction or kind of recommending next best action, you want to turn it into a nice table to actually have features, right, that you can use in your model to understand, okay, here are the diagnoses, here's where the vitals are abnormal, and here's what we want to do next about it. So first of all, I want to talk about how the flow usually works, because usually what you see is that there's going to be kind of a pipeline. In NLP, it's just an NLP pipeline. Usual pipelines that we see in production have 40, 50, 60 steps. You go in OCR documents because they're images or they're scanned documents. Today, even you don't actually OCR and continue, you actually do some computer vision directly on top of the images. Then, usually you really need to de-identify, either because you're legally required to do it, or to avoid data leakage of sensitive data into the model, right? So you don't know, I've seen this before, models that are trained to recognize patient names, right? And so, if you see this name, it means they have this disease, which is really not what you want the model to learn. Then you want to be able to classify documents, because what happens in healthcare is that different types of documents basically use different language. Okay, and you can relate to this yourself, right? If you go if you get a pathology report, right? Usually you will take the printed report and you will go to another doctor basically to translate it to English. Okay, and the doctor needs to understand this, right? So your cardiologist is not your dentist for a reason, but they actually do different things. And the models, the NLP models you need to train for each of these are different as well. And then very often you need to extract named entities. And I mean, currently there are more than 400 entities we do out of the box, and it keeps growing. There's a lot of diversity on what you care about, from social determinants of health, lab results, radiology, insights, tumor measurements, teeth, and many different things in many different contexts. After the entities themselves, another thing that's very important to semantically understand is what are you asserting about each entity. So you have to be able to differentiate between patient is diabetic versus patient is not diabetic, versus a patient shows symptoms of diabetes, right? So that's a maybe, versus patient's mother was a diabetic, so that's family history, right? Similarly, you need to be able to differentiate between past, present, and future, right? So I had a surgery 10 years ago versus the surgery is planned for next month. Obviously, these mean different things, right? If you're trying to match a patient to a clinical trial, I'd suggest the next course of action, see if they're a fit, right, to a specific study. And finally, you want to do entity resolution, which means you want to normalize terms into codes, right? So if you cannot tell that diabetes and diabetic and type 2 diabetes mellitus and T2DM and sugar intolerant are actually the same thing, then you do studies and you'll find that diabetes is not related to risk of mortality, right? Because you took that one feature and you split it into like 6, 7 features, because just people use different terms in different things. So you have to be able to group things together and kind of say, oh, this is actually the same kind of underlying clinical thing that I care about, right? To do any downstream machine learning on top of it. So there's that as well, and you need to train models to do it, because you need to be able to do it in context. You need to use embeddings and sentence embedding and language models to really understand what does this then mean, what should I normalize it to within this context. The most important thing you need to do if you want to build these models is really start with a manual process, have actual medical doctors who understand the clinical semantics, and have them reach agreement on what something means. Okay, and this is hard because okay, tell people like I'm yet to see two teams anywhere in the industry, even within the same pharma companies, who agree on, for example, the definition of cancer staging. Okay, which is supposed to be this super standard industry agreed thing. Okay, if you talk to doctors, they don't even agree on the definition of gender, right? Like how would you classify patients based on gender? Okay, and if you go into specialties, you can say, oh, well, how should we treat these cancer patients, right? These ophthalmology patients, these dental patients. Definitely, if you go into mental health, it's very subjective. The first thing you need to do is to actually write down the annotation guidelines, come say, okay, what actually are we trying to model? How do we label things? Okay, read some agreement on that. And then what you do is, every week you validate and you handle the disagreement. And one of the things that happen in healthcare is that in the third year of a project, you will find new exceptions and new things that you still need to update. Okay, I think for me, when I got into healthcare about 10 years ago, I completely underestimated just the variety of language and just how specialized things can be. Okay, and really, you should expect that you will never ever be done with defining those guidelines. Okay, there's always going to be another special patients you haven't seen, and if you know people who are doctors, they will tell you, I've been a doctor in cardiology for 30 years, I've never seen this kind of case. Okay, this is just how healthcare is like. Once you have the process, what you really want is this kind of augmented process, where you automate really 90% of what you do if you do it manually, by starting with a pre-trained model. Okay, so for example, if I'm trying to build a model to recognize vaccine, I'll start with the general treatment models and just delete the other treatments. I use it to pre-annotate the data, the documents that get loaded. Individuals will fix it, will validate, will tune to the specific definitions. Okay, we very often see this kind of, with our own kind of customers' implementation. Because what we call the vaccine, they call it something slightly different, right? What we call, for example, a patient that's kind of experienced violence in the home, they consider it something different. At risk for kidney disease, they have a slightly definition for what they mean, what is relevant to them. And then you want to retrain the model automatically in the background, right? So as more things get annotated, you retrain the model, you update, until at some point, basically, you reach some equilibrium where people will tell you, look, we can stop now. We've stopped fixing things, right? It seems to kind of have stabilized. And if you do it well, really, this process usually is 4 to 5 times faster kind of overall than the process without the automation behind it. The other cool thing that you have is you get all of this done without any data scientist being involved. Okay, and one of the things I like to show you next is actually a completely free tool that's out there that enables you to do this end-to-end no-code process. So it's an annotation tool. We actually have doctors, we have our own doctors, and right now so in 2 customers, medical doctors, they actually train and publish models without any data scientists being involved. Okay, and it's hard work because you do need to specialize. As you see, we have people who have we have a couple of implementations, we have more than 1,000 live projects, where people can go build teams and define those documents. What you go in, you define projects. Within a project, you kind of say, okay, here are the steps. Here are the entities I care about. Here are the assertions I care about. Here are the relationships that I need to explore, right? Here are the kinds of documents. Of course, especially in healthcare, all of the kind of the security compliance features have to be there. So single sign-on, versioning, full audit trail, right, has to be there, because 5 years down the road, a regulator would come and ask, which model did you use on this patient at this date, and why did you make this decision? And by the way, it's a fair question, because like someday I'm the patient, I want my pharma company to answer that, right? And one of the good things with healthcare is all of the responsible AI, MLOps stuff that now we begin talking about, in healthcare you do them first. You do them before you deploy the first model. Okay, and that's actually one of the things I really like about the industry. A lot of things happen come at the right time. Once you have a project, people go and annotate data, and there's a good differentiation between predictions that the model proposed and completions that the human did, and you can decide what they accept, what they don't, and then you can, there's workflow, you can compare between humans, you can do compare versions, you can send things for validation, and at some point you say something like, look, all of the things that have passed this, for example, maybe just were completed by human, maybe actually passed the review, were corrected, right, have no more comments, are ready to move to model training. And model training is also something that happens automatically for you in the background. And engineering-wise, this is done nicely. It's in Kubernetes, and you can have multiple trainings running in parallel. You can do it on GPUs. You can do all of that. This works for large teams that have multiple projects running in parallel. But at the end, what you want, you have tasks. Once you decide that they are right for training, you can do this manually. You can automate this. You can say, okay, please train a new version of the model. And you can do either train a fresh model, or you can do transfer learning, kind of start with the previous model on existing model and basically update it, right, to the data you've trained here. The really nice thing about transfer learning is really things that, 4 years ago, 5 years ago, would take maybe 5,000 documents, 6,000 documents. You can do now with 60 patients, 100 patients, right, and get very good results. Real technology looks really nice. As you can see, you can decide what the training type is, what embeddings you use for different types of models, what are the parameters, and then you can actually go and let it train. Once it trains, there's a model, it goes into a model repository. You can decide whether you want to use it going forward or not. Right? Some things come in before we use it, we want it to go for more testing, right? And they have their own procedure. And some teams can say, okay, let's just, I don't know what model testing is because there's no data scientist here. Just start using it here so we can do it that way. And at the end, you just go, you deploy the new model, and that's it. Okay, so without going into all the details, the main thing to know, this tool is completely free, including all the scaling features, the security features, everything you've seen here. It's been used right now by more than 100 different companies with the explicit goal of allowing domain experts to go and build and especially tune those types of models, right? Basically translate their own domain expertise right into deployed model that actually get deployed and used without any data science. On top of it, if you're in any space, but especially if you're in the healthcare space, there are concerns about responsible AI, and that's a very broad problem. Just like driving safety, right? Yes, some things are responsibility of the driver, some responsibility of the car, some responsibility of the government, and how they build the roads. It's a big thing, but part of it is our responsibility, right? As the people who build the models, and there are some tools that we need to provide so that it's easier to build safe and reliable models. What I'm going to show you here is heavily inspired by these two projects. These are two open source projects, Checklist and CleanLab. They are public academic papers, public open source projects that you can try and use. And basically what we've tried is we've productized them and specifically applied them into the healthcare space. And there are 5 kind of things that the software does right now. One thing is testing a model for basically small perturbations. What happens if I introduce spelling mistakes? If I change uppercase to lowercase, is the model still stable? So one of the nice things that the checklist paper showed, that the focus was on sentiment analysis. But it showed that, for example, if you make a statement more extreme, so you said, this was a horrible experience, but then you change it to this was a horrible experience, you are lame, in 20% of the cases, this actually flipped the sentiment to positive. Okay, and there were all kinds of those minor changes that showed the models were actually very, very fragile. So what you want is you want to test it in this way. But because we know how to automatically generate those examples, right? Because those are basically like the simplest cases of language generation, right? You need to change something to a negative, right? Change entities, expand the sentence. We just found that we can actually generate more training data that's already labeled. So what if we just actually apply it and try to do the same tests? Can we actually use it to fix things? So that's another thing. The third thing you want to do that's super important is to identify bad labels. Okay, so one of the challenges, especially as you get to kind of the 90% accuracy, is that very often you find that actually a lot of the remaining 10%, the labels are actually wrong. Okay, so the human experts who did it, they got it wrong, or they disagree with one another. Okay, if different humans disagree with one another's model, they correctly represent noise by randomly picking stuff. So one of the things that you want to do is try to see, okay, when can we automatically, heuristically, try to find out the labels that are likely wrong, and if we can find them, can you please just fix them automatically also and retrain and tell me how you're doing, right? So that the whole thing happens for me. And the fifth most important thing is looking at bias detection. Okay, and in healthcare, there are many things you care about. The most basic things are, does the model work the same based on gender? Second thing you care about is age group. The third thing is race and ethnicity. But also there are definitely cases, for example, you have the cancer model, you want to know, does this work the same on stage 3 versus stage 4 patients, right? How well does this work on pregnant people, on diabetic people? And so there are always more dimensions you care about. So I'm not going to go into detail, but for each one of those, there is actual code that's running and available as one line of code, and you're welcome to actually download and try it. But I just want to talk a bit more detail about each case here. So if you're looking at perturbation, so the classic things that you can use in any vertical, introducing typos, replacing synonyms, replacing verbs with similar verbs, right? And so if I really like this, change it to I love this, if your model still gives you the same result. But especially in healthcare, for example, we look not just at synonyms, but we look at things from the same class. So what if I replace a drug with another drug from the same class? What if I replace a symptom for another symptom, but from the same body system? Okay, we see a lot of things that fail because of this, right? Because maybe there are other things that you've just never seen in the training data set otherwise. We look definitely things like capitalization, titles, they actually do matter, punctuation, because a lot of what you do in clinical notes, you use shorthands. Okay, you use lab result, test result, you use this/this, you use decimal points in the wrong ways. So very often, even changing one space changes the actual meaning. One of the things you can see here is an example of generating some of those tests, things that you failed them, and then really just pulling it back into your training data, retraining the model, and testing it to the same test set. Okay, now obviously this is not the only thing you want to do, because some of those automated examples may actually be wrong, and you should look at them manually. Okay, another thing you don't want to do this 30 times because you're overfitting on the test set, even though you haven't actually changed it. Okay, but what we do see is very often, if you just run the whole test suite, we start with comes, okay, just edit once and see what you get. And then a human would go and review it from that point on. In terms of noise level detection, there are several good heuristics to try to guess which labels in your training data or test data are probably wrong. Okay, if you look at it intuitively, one thing you can do is just compare it to another model. For example, if you have a zero-shot model, right, which we have now, just kind of say if the label data strongly agree with the zero-shot model, yeah, just prioritize, someone should look into this. Another thing that often helps is train the model on your training data. Okay, and then run that model, do inference on the training data set. Okay, so of course you can't use for measurement because you're strengthening, but if your own model strongly disagrees with the label you gave it as an input, it probably means that you have an outlier. Okay, and very often these are actually, you look at it and can say, yep, you don't get it wrong. It shouldn't be that. But basically, so usually what we do, we combine right now 7 heuristics to basically give you a ranked list that kind of says, look, those are suspect labels. Okay, and then yes, you do need to go one comes out, yeah, no, this is actually correct. Most cases, what you do is you look at the top 20 and you kind of say, yep, all of them are actually wrong. And then what you do, and you get this table in kind of Jupyter, and you can click around it, or you can just do kind of select multiple and kind of say, yeah, please just fix the training data. Okay, and you fix the labels, and then you can retrain, right, and you get more stable and more accurate results. The last thing that's important is bias. With bias within healthcare, it's a more well-defined problem, because if you look at the patient note, the patient note actually has a gender. It's the gender of the patient, right? Which you don't, if you have a Wikipedia article, right, or you generate a blog post, it does not have a gender, right? It's kind of harder to assess when it includes gender bias. But what you can do, if you have any clinical classifier regressor, is if you can automatically classify the patient note, and we have those classifiers, right? You can say, okay, what gender is the patient that this story is about? What age group is the patient this story is about? What is the race of ethnicity? Then you can generate F-scores by gender, for example, right? As you can see the example here, in a completely automated way, right? So you don't need to tell me anything more, just give me the training and test data set and give me a way to do inferencing, and I can give you that, and also, so basically we just build the tools that do that for you. Another thing you want to check is whether you even have enough examples to make any statement, right, about specific, especially age group. right? So it's one thing to come and say, oh, this produces 0.86 on women and 0.76 on males. But for example, you can look at something like age, and to come say, look, this model, I'm not even going to give you a number for anyone under 21 years old. Just this model does not apply. Okay, because you have so few examples in your training and test data, right? That basically the correct answer is this model does not apply. Okay, and that happens a lot in healthcare. COVID vaccine, we started, we only tested this on adults, right? Adults who are not pregnant, not on chemo, not on other vaccines, right? And because that was the safe population, we want people to get a vaccine as soon as possible. What we'll do with kids, we'll do another trial later, and then we can vaccinate kids, right? And a lot of things, like, for example, a lot of the breast cancer research is only done on women because it's 98% women, right? There are many other cases where, when you do something and you only do it for a subset of the population, and that's okay as long as you're explicit about it, right? You can say these results only apply to this ethnicity, age group, or gender. So, those are the kind of things that are available to you. As I said, one thing you can use now, really, the annotation lab with all this functionality is completely free. It's for enterprise use. You can install it on-premise. You don't share your data with anyone or with us. It's designed for high compliance air-gap environment. So there really is no catch here. Used quite heavily. There's a whole team developing it. We have quite a few people who are contributing into doing this. We are investing a lot in the responsible AI space. The goal is to expand this. One thing that we know we still want to add is to check for a leakage of sensitive entities, so personally identifiable information. But I would say even within what I've shown you here, there are more tests and just basically deeper testing you can do to each and every one of those cases. And the goal is to make this work, to make it scalable, and really just make this freely available to the community. And with that, thank you.
Questions? Yes, thank you. So, what make the difference? So, what's the difference between the medical knowledge that make it very different and difficult to translate compared to the other type of knowledge, like the common knowledge we see every day in the magazine or newspaper?
Yep. So, in general, in medicine, first of all, just really, it's a different language. If you look at the clinical route, people use a different language, use different vocabulary, different grammar, different meaning. And really, like I often tell people, if you want to learn how to read a radiology report, it will be easier for you to learn Russian or to learn Portuguese. It just takes less time. Okay, there are few new terms you need to learn to be able to do that. So definitely requires different model. Even academically, you see people just, it's like different conferences, different events, different benchmarks. So that's a simple story. It's just a completely different language. Other than that, you always want to make sure models are tuned right to a specific question, right? Usually it's not just entities, you care about question answering, paraphrasing, right? The specific semantic information you care to extract.
What are some of the more interesting projects that you've seen run on this platform?
Healthcare is very exciting in that way. You see a lot of stuff that actually helps people. We see a lot of work on identifying patients at risk. So this includes, for example, identify people who have chronic disease, basically before they wake up in the ER, being told that they're going to be on dialysis for now. So trying to do it several months in advance. Especially with NLP, there's a lot of work on mental health. So undiagnosed depression, suicide ideation, those types of conditions. Another area where NLP is hugely applicable is oncology. One of the challenges specifically in oncology is that the structural data that you have actually tells you fairly little. Even if you just want to know basically cancer staging, tumor histology, you need to read the pathology reports, radiology reports, which means that even to know really what disease you have and which doctor to send you to, you need to understand the notes. So oncology is one of those areas where matching patients to clinical trial, getting patients kind of the right treatment plan, matching kind of to cohort for research studies is something that this is very widely used for across the industry. Other than that, within NLP, there's just even monitoring patient messages for social media, for adverse events, right? So bad things that happen to people when they take drugs. We have several interesting projects for example, like a directly life-saving thing, classic messages from patients. So what we saw, we saw this with two large West Coast health systems. People send messages to the doctors or to the health system, right? And about 1 to 2% of those messages are actually clinically urgent. Okay, and this is like you wouldn't believe this. You read it comes out how this person like type a message into the cell phone or a screen and not just go to the app, right? But the thing is, 1 to 2% of messages is several hundred people per day. Okay, so if you can automatically catch it within the first minute, right, not after 48 hours when someone looks at it, and have an else call the person, you can save people. So those are some of the other things that are behind this. But I say definitely look with the, I would say deep learning, transfer learning definitely changed the game in terms of what's doable, in terms of accuracy. And really, there's a whole wave of use cases that have been enabled now, and we are seeing them come to market.
Amazing.
I had one question for you. So, as you mentioned this, it's almost a different language, I mean, the medical.
It's a different language.
I'm kind of curious, man, how are you dealing, there's a very high premium on accuracy of your translation and making sure you're not misclassifying entities and going in the wrong places. Like, what steps have been done in the tool to actually help make sure that this is stable and it's not inaccurate? Because the results can be disastrous in the interpretation later. Yeah.
Yes. So look, first of all, especially in healthcare, actually it's one of the most ethical industries I've been in, right? Because if you talk to healthcare professionals, this is just yet another healthcare technology. Okay, we've been applying technology in healthcare for the past 7,000 years. Lots of people claim stuff, very little of it works, but there's actually, really, they have an ethical process we need to learn from. Okay, that's the one industry that's all about that from the beginning. So here, the first thing is you need to know what use case are you going to apply this to. Okay, for example, look, most NLP models, no, you would not use to automatically adjust your dosage. Okay, and you just wouldn't. Not first of all because the models are imperfect, but also because what's written in those notes are imperfect, right? So like there's a reason, when you go, to the hospital, even if you were there last week, they'll redo your blood, okay? Because they know that in 2-3% of the cases they didn't actually input the right thing last week, or they copy pasted it, or it got lost, okay? So before we literally kill you, right, we are going to do this again and again and again just to be sure, right? So there's a lot of what people do within the health system because they know that the system is imperfect. So that's one thing. So you really need to understand what you get out of it, right? Other than that, in terms of accuracy, I would say, especially for the context here, when you can take in human expertise, I would say the most important thing is agreement between experts. Okay, and this is a lot of the process that the tool helps with, right? And think about a lot of healthcare is undecided and controversial. Okay, so let's say decide, who am I going? I want to find high-risk patients that I want to refer to gender-affirming care, right? I think there are high-risk pregnancies. Okay, no two people will agree on what the definition is. Okay, especially people who have been doing this for 30 years with real patients. Okay, and for good reason, right? Because really, it's an open problem. Okay, so what you need to understand is, look, if people don't agree, the model will definitely not agree, right? And you can just throw random numbers, and any machine learning model would put down that. But that's one thing. Define agreement, okay, and decide really what you can do, what you cannot do. And there are a lot of tools really around audit and versioning, comparing versions, having commenting, having the guidelines in the tool, updating the tool, showing you productivity, showing you disagreement at the very fine-grained level, so you can go one by one. So that's a lot of what people who use the tool actually use. The other thing are really some of those new tests, right? Where you can show people, look, yes, you've been working on this for 2 months. Look, those labels, I think we're wrong. I think they're wrong. If they're not wrong, at least you should look at them again because they're definitely outliers, right? So you want to look at them. Also, bias is a hard problem because especially if you start with free text, very in the beginning, you don't know yet how biased you'll be. Right? Because, for example, if you need to extract ethnicity from the text, right? Initially, you put in 5,000 people, you don't know the ethnicities, right? So only after you've done this, you can say, hey, you're actually like really low on, Hawaiian, right? Original, right? You cannot actually make a statement about that. So that's another thing that I think would help. But at the end, technology can only do what it can do, right? It's not magic.
Wonderful. Thank you so much, Dr. Gabby. Yeah.
Thank you.